So let's get a little bit of a start on Wednesday. Mass calculations. So what we were just talking about is ratios of moles of one thing to another and how we can get that information from the balanced chemical equation. Moles are awesome, and yet they're not useful for measuring out quantities because the balance doesn't weigh things in moles. We have no device that'll measure out 5 moles of carbon. We weigh them out by mass. And so we need to be able to calculate masses of reactants and masses of products from the chemical equation. So what we're going to do is we're going to add a step on each end. What we've been doing is going from moles of one thing to moles of another thing. So we've been going from moles, let's just call it moles of A to moles of B. And what we're going to do is we're going to start with grams of A, because we could weigh that, and convert to moles of A, and then to moles of B, and then convert to grams of B. And this up here is the big idea of what's called stoichiometry. Grams to moles to moles to grams. That's the path. And you just kind of chant it. And when you wake up in the middle of the night murmuring grams to moles to moles to grams, that's when you know that you've got it. Okay, grams to moles to moles to grams. So what we just learned how to do was convert moles of one thing to moles of another thing using the ratios we get from the balanced chemical equation. Now we're going to add on something that we already learned to the beginning and the end of that, converting grams to moles. That's using molar masses, and we covered that in Chapter 8. So here are the steps for calculating masses of reactants and products. The first thing is to balance the equation for the reaction. Now, on exams, you'll be given the balanced equation. In some of the homework problems, they make you balance it. It's good practice because you need to remember how to do that. Always check your equation, though, and make sure that it's balanced. The next step is you convert the masses of the reactant or product, whichever one they're giving you, to moles. Then you use the balanced equation to find the mole ratio. You use the mole ratio to calculate the number of moles, and then you convert the moles back to masses. And this is the big idea: grams to moles to moles to grams. This is called stoichiometry. It's a process of using the chemical equation to determine amounts of reactants and products. And they could both be reactants, like with the sandwiches. You say, okay, well, I've got 200 pieces of bread. How many pieces of meat do I need to buy so that I can use up all the bread? Or something like that. Or I've got, 50 pieces of cheese. How many pieces of bread do I need? Or it can be, if I've got this much product, how much reactant was used to make it. All different combinations. So let's look at an example here. It's a simple equation. Chromium reacting with oxygen to form chromium oxide. Now they're pointing out unbalanced equation. First thing, balance the equation. So generally, starting on the left works pretty well. So here, it's not in this one, but we'll do it anyway. Here's chromium. There's 1 on the left and 2 on the right. So if I put a 2 in front of the chromium, now I've got 2 chromiums on the left, and I've got 2 on the right. Now I look at the oxygens. Here I've got 2 oxygens, and there I've got 3 oxygens. This is what I call an odd-even problem, right? Because on the left, they're coming in pairs. You can't go to the shoe store and buy an odd number of shoes. They only sell them in pairs, right? And here, these oxygen atoms are coming in pairs. But over here, I need an odd number. So the solution to that is double everything. Because when you double an odd number, it magically becomes an even number, right? So I'm going to take my 2, and I'm going to make that into a 4. The number here was a 1, So that doubles, becomes 2. I'm going to leave the oxygen alone because that's the one I'm currently messing with. I hadn't decided what that should be yet, so I was just going to leave that alone. So now let's double check our chromiums. There's 4 on that side, and there's 2 times 2, 4 on that side, so that's okay. Now, on the right side, we need 6 oxygens, and over here, they're coming in pairs, but that's okay, because if we have 3 pairs, we'll get 6. Okay, I think that's the best way out of those odd-even problems. So balance the equation, first step. Now the question says, how many grams of chromium-3 oxide can be produced from 15.0 grams of solid chromium and excess oxygen gas? Always read through the problem once. And if it makes no sense at all, read through it again. Say it out loud if you need to. There's no point in continuing to do something where you don't understand the instruction. I see that in classes periodically. They'll just, well, I didn't really understand what I was supposed to be doing, but I just decided to go do something anyway. Okay, if you don't know what you're doing, ask for help. So I read through the question. There's a number in here. We can use this balanced chemical equation to help us organize the information. So if this was given to you balanced, write it down on your paper. Okay, make sure it's written down on your paper so that you can use it to organize the information. How many grams chromium-3 oxide? Well, even if you're a little sketchy on your nomenclature, hopefully you can pick out that it must be this guy, right? Because that's chromium, and this is oxygen. This must be the chromium oxide. So the question is, question mark, how many grams of that guy can be produced from 15.0 grams of solid chromium? So here under chromium, I'm going to write 15.0 grams of chromium. So my path is going to be grams to moles to grams. This is what I'm starting with, and this is what I'm going to end up with. I'm going to go from grams of chromium, I'm going to convert to moles of chromium. From moles of chromium, I'm going to convert to moles of what I'm looking for. And then I'm going to convert that to grams. And we're not going to finish this one, but I think it's just a good jump start here. The thing we learned today was how to do this, moles of chromium to moles of chromium oxide. What's the relationship between those? If I had a ratio like this, what number do I put in front of Cr2O3? 2. Because 2 moles of this are produced from 4 moles of chromium. So I would have a 4 down there. And that's going to be my middle term, converting from chromium, moles of chromium, to moles of chromium oxide. The last step is the molar mass of chromium-3 oxide. The first step is the molar mass of chromium. And we'll pick that up again on Wednesday.